Hello, my name is Brian Gray. I am a PhD student at DePaul University and an instructor of computer and information sciences at Harrisburg University of Science and Technology. And I am presenting today a research on teaching space science to middle schoolers using serious games in a post-COVID world. Today I'm presenting for my co-investigators, Dr. Salu, also of Harrisburg University of Science and Technology, and my PhD advisor, Dr. Peter Hastings of DePaul University. So to give you an idea of what we did, we created a game called Space Escape, and we've done a couple of experiments with it now, one of which I will tell you about today. Space Escape is a mobile serious game, a game that's designed to teach space science to sixth graders, really middle schoolers. So it's designed to teach middle school students about the solar system and about space. And it was designed for Android, so it is a mobile-only application at this point. We are currently in the process of porting it to a web application using Unity, and we will talk more about our future developments on that. But previously, it was available for download to any sort of mobile device or phone via the Google Play Store. So we created this application, we created this game in tandem with undergraduate students at Harrisburg University of Science and Technology. They did most of the design, most of the implementation, and it is sort of space-based. Where in the world is Carmen Sandiego? The idea is that students would play the game, and the storyline is Lucy, the little girl in the title screen up there, gets abducted by an alien mother who's looking for a play date for her son. And she drops a walkie-talkie, that little thing that you see on the screen, the gameplay screen in the bottom right. Her dog Spark finds the walkie-talkie, takes it to Lucy's dad, who lets them know that she's been kidnapped by aliens. And so you play as Spark and Lucy's father, who are trying to find Lucy by following her clues throughout the solar system. So Lucy will send you a message saying, "Oh, I see lots of clouds here," and you'll have to figure out, based on exploring various planets, various planetary bodies, such as the dwarf planet Pluto, the eight planets of the solar system, and major moons of those planets. You have to figure out, okay, well, she's somewhere with an atmosphere. Oh, it's cold. Okay, so it's atmosphere and it's cold, so it can't be Venus. That sort of thing. And eventually you take a few guesses and you try to find where she is. So that is how the game is played. And back in 2019, we did some initial work with this. We went to a local school district and we were in the classroom, Dr. Liu, myself, and another instructor at Harrisburg University, Professor Mina Gabriel. And we did our research in the classroom. We were there the day before to get the game set up on students' Chromebooks and to conduct the pretest. And the pretest was 10 questions about the solar system, as well as a little demographic information. Are you interested in science? Are you interested in space science? What gender do you identify with? That sort of thing. We had 226 participants that we could use, split between experimental and control group. And you can see the results on the screen. For game performance, broken down a couple of different ways. The day of the experiment, it was an additional classroom. It was an additional class on space science. They'd already done some work on the solar system in their science class. So we came in, they played the game for 40 minutes, the experimental group did. The control group just, noodled around on their Chromebook looking at science-related stuff. And then they did a post-test immediately afterwards. And each group had significant improvement on their test. The experimental groups had the greatest improvement, but even the control group had improvement. So this kind of made us think, we need to do a little more investigating on this. So we took feedback from the students The post test also had information about, hey, what did you like about Space Escape? What didn't you like? How would you improve it? That sort of thing. And we conducted a follow-up study in 2020. And our initial design was that we teamed with another school district. We were looking at another group of students that were 200 plus participants. While we knew at the time the number of students that we had available to us, we never really were concerned with that specific number because we anticipated only being able to use student data if they were able to complete all three aspects of our experimental design. And so if they missed the pre-test, they'd be able to come in on the day of the experiment and they'd be able to play Space Escape, but we probably wouldn't be able to use their data. So we settled on 200 plus participants. We added some features within the game of Space Escape during that time. It mostly involved action logging. So every time a player would click on something, we would get a log of the player who did it, their ID, and what they did and the timestamp, so that we can go back and mine that later on, as well as this quality of life improvements that students suggested. These are small tweaks such as sound effects or animations on the screen that would clue students into what was making the sound or what was the active element on the screen, small stuff like that. We also added a retention test to be administered 2 weeks post-intervention. So the students would retake the post-test 2 weeks later to see how much of the information they had held on to, because that's really what we're concerned about. If they know a whole lot about space science immediately after playing the game and then it's all gone in 2 weeks, what's the true benefit? And we added some control questions to the pre-test, the post-test, and the retention test. The goal of which was to sort of control for the test effect. These control questions would be in the realm of solar system or space science, so they wouldn't really raise any attention, red flags. These are special questions, but they wouldn't be taught by Space Escape. So the goal was to be able to use those as sort of a canary in the coal mine and to understand what our baseline is. And then, as many research presentations are probably going to be saying over the next couple of years, then the pandemic happened. And we had to ask ourselves, do we want to hold off? Because all the school systems went online by the end of March, and we were planning on being in the classroom in May, and you can't do it. You can't be present during the pandemic the way that we wanted to be. So what we decided to do was, rather than wait for the world to get back to whatever normal would be or is at this point, we documented the process. We spoke to the school district, we spoke to the science teachers we were going to work with, and we sent them the process for setting up the application, the testing schedule, all that. And we passed it along to teachers. We asked them to pass it along to the students, and students were encouraged to install Space Escape on their school issued Chromebooks. And then we encourage teachers to encourage students to play the game as part of class or an independent learning activity. And for those of you who are school teachers or have children in school, you'll remember that point in time, school was still kind of figuring out what this online environment is. We saw this as a useful way to gain meaningful data on what this sort of distributed, non-regulated learning could look like, would be, what the results would be. We hypothesized that student participation would be reduced basically in any way that you looked at it. We hypothesized that some students just wouldn't even do it, and that many students would only do a certain aspect of it. They might start doing it and then go, I'm not going to finish the experiment. Or they might go, well, let me play the game and I'll take the post-test or something like that. And we also hypothesized that because of that sort of unregulated, loosey-goosey environment, post-test performance would be reduced. And we anticipated that the retention test would be less than the post-test, which is standard operating procedure for what a delayed retention test looks like. Our results were both exactly what we thought and nothing like what we thought. We had over 200 sixth graders that we had in a potential pool of participants, and only 137 of them completed at least one of the tests. Even less than that, 12.4% of participants, 17 in total, 12 girls and 5 boys, completed all aspects, pre, post, and retention test. So that was sort of as expected. And this next fact I bring up because the results kind of require this. Students were overwhelmingly interested in space science. Over 80% of students who did the pretest and 88% of our students who did all of the tests were interested in space science. This is relevant because when we looked at our experimental questions, the stuff that was taught by Space Escape, we had an improvement from pre to post test of 15.5 points, which is significant, which is statistically significant. And on the retention test, they actually went up by 1.2 additional points over the post test. Obviously, this is also statistically significant compared with the pretest. The difference between the post and the retention test was not statistically significant. So playing the game caused students to score much higher. What we found really interesting, though, was once we included control questions, the pretest scores went up because you got a couple of extra questions, literally 2 extra questions. Post-test scores and retention test scores went up more. So what this means is that the results with the control questions made the tests even more statistically significant, made the test gains even more statistically significant. As you can see by the graph on the right, the control questions, when you considered all answers, were answered at 50% rate in the pretest and would go all the way up north of 70% on the retention test. If you remove the students who just said not sure, we included a not sure answer on every single question. If we only look at the students who answered the question rather than punting, their accuracy goes up to a little below 50% on the pretest and goes all the way up to almost 75% on the post-test. So this is interesting. The thing that we meant to control for, they are less effective at learning that than the other things, but their increase in performance is similar, follows a similar trend to the experimental questions. So these are obviously very preliminary results. And the sample size is low, so we do have to account for that. But learning rates were significant and followed the pattern that we had hoped for and expected. Performance on the control questions, though, that's still the confusion on our part. Why? Was it a poor choice of control questions? Was it due to a small N? Right? We only had 17 students, which is absolutely acceptable for a pilot study, but is, a smaller number than we were hoping for. Or is it that students had high interest in this information, and could Space Escape have led them to what we hope a serious game would do, which is not just teach them through the game, but also encourage them to do their own research? Oh, I wonder why. What are the moons of Uranus named after? Are they Spanish words? Are they Greek gods, or are they Shakespearean characters? I should look that up. I don't know. And if that's the case, that is exactly what we want. So work that we're continuing to do, as I said, we are working on porting Space Escape to a web application so it would be available on all platforms. We are continuing to mine our existing data and the behavior logs of students in game. we're working on figuring out why students perform so much better on the control questions than we anticipate and why that improvement is as strong as it is. And we're going to start looking at how effective the knowledge that they gain transfers from the game to other contexts. Because that's really the other thing that we're interested in teaching, right? We want to teach them, we want to get them interested in a topic, but we also want them to be able to use that topic, be able to understand more about the world, understand more about whatever topic they're learning about, and use it in their day-to-day lives. So this is ongoing research. We do have a website, harrisburgu.edu/spaceescape. And we do have a contact email, spaceescape@harrisburgu.edu. Please do go take a look, check it out, and please send us any questions, any thoughts you have, and any follow-ups that you have. And I appreciate your time and thank you for coming.